Hey, howdy. So in this video, I'll show you how to make an explosion VFX in Godot engine. And this shader that we're gonna write will sample a flipbook texture. And we're gonna do some motion vector frame blending. So this flipbook that you're seeing is only 25 frames. But if I make it play slower, you'll see that it is playing really smoothly. That is because we are using some optical flow motion vector texture, and we also have some depth fading based on some depth map. So as you can see, whenever the explosion is intersecting with some other geometry, it's fading based on depth. And we're also going to write this heat distortion sort of shockwave shader, which also uses the motion vector texture. We also have some dynamic lighting with backlighting and normal maps for receiving light from different directions, and some other cool VFX techniques. So let's get into it. Alright, so first things first, the textures. So here we have a normal map that we're going to use for improving the lighting on the flipbook. We also have an optical flow motion vector flow map, which we're going to use for frame blending. And we have this depth map that we're going to use for proximity fading. And then we have the heat map, which is basically the flame rendered in grayscale. We can use a gradient, or we can use a blackbody radiation function to turn this into to colorize this basically. And then we have the base color of our smoke, and then we have the backscattering or the backlighting of the smoke. Now I've rendered these out of Blender, and I have a video on making flipbooks with motion vector textures. I don't have a video on making normal maps for volumes. This is kind of a hacky way of making normal maps. You kind of light it from different directions and encode it into a normal map. Let me know if you need me to make a tutorial on rendering normal maps for volumes in Blender. But if you use a specialized software like Embergen, I believe you have options for exporting all of these maps that we have here: normal maps, motion vectors, depth map, and all the other stuff. Alright, so before we get into writing the shader, we want to channel pack 3 of these textures, because as you can see, they're all grayscaled. And so we can pack them into the RGB of one texture so that we can sample once in the shader instead of sampling multiple times. So I'm going to channel pack the heat map, the backscattering, and the base color into one texture, and I'm going to use GIMP for that. Alright, so here's the base color, and if you look at the channels, this has a transparency in the alpha channel, but the R, G, and B channels are all identical because this is gray. So what we're going to do now is we're going to go to Color, Components, Decompose. And we're going to decompose all the RGBA channels. And this will give us the red, green, blue, and alpha channels as different layers. Now what we can do now is we can open our backscattering as a layer. And I want that to be the green channel, so I'm gonna delete the green channel and replace it with this backscattering. And we're also going to pack this heat map into the blue channel. So I'm gonna delete the blue channel and replace it with our heat map. Alright, so now we can go to colors, components, and compose. And we're going to compose RGBA using our layers. And this will give us something that looks like this. Now, in the shader, we can use the different channels. We can use the red channel for the base color. The green channel will give us the backscattering, and the blue channel will give us the fiery bits. Alright, so we can export this as a PNG, and we want to check save color values from transparent pixels just to make sure we don't miss any data in the transparent pixels. Alright, so this is going to be the texture that we're going to use instead of these, so we can just delete these 3 textures and we're going to use these 4. This one is going to be our mask map because it has our heat mask, backscattering, and base color. We can rename it to masks or something like that. Alrighty, so here we are in Godot engine, and I've already imported the textures here. Let's start by adding a mesh instance 3D, and let's give it a quad mesh. Where's this? Here it is. Here's our quad mesh, and let's make it a little bigger, something like 5 by 5. And well, it's a bit too big, I think. Maybe 3 by 3. And we're gonna give it a new material. Well, let's first start using a standard material 3D, because we're gonna use some of the functionalities from here, namely the billboarding. So I'm gonna enable particle billboard and also proximity fade. And now we can convert this to a shader material, and let's open the shader. Now we can swap this for a shader material and create a new shader, and we can call this something like explosion flipbook or something. And we're gonna open this as well. Alright, so this is our shader. It's empty. We're gonna copy some of the lines from this shader, this generated shader. So we're gonna need this line, the depth texture uniform. And we're gonna copy these lines here for the billboarding. We're gonna paste it in the vertex shader, and let's copy these lines for the proximity fade and paste it in our fragment processor. Well, we don't need it right now, so let's just comment it for now. And that's all we need from our from this generated shader. Now we can just close it. Alright, so now as you can see, we have billboarding, and don't worry about this weird shading that's going on here. Once we add a normal map to it, it's gonna be this issue will be resolved, so let's not worry about that right now. Alright, so let's add a couple uniforms for our textures. So I'm gonna add a uniform sampler 2D for our mask map, and another one for our normal map. And here in our fragment shader, we're going to sample our masks. Mask map UV, and we stored the base color in the red channel, but it's a grayscale value, so we can set the albedo to a vector 3 from the masks.r, and we can set the alpha to be the masks.a. Alright, so now if you assign our textures here, you can see that we have the base color. Let's add our normal map, and let's sample our normal map as well. So normal map equals normal map dot xyz. And now it's not very noticeable, but we have dynamic lighting going on. I think maybe if we make it a little bigger, it would be more obvious. So we want to display one frame at a time, not the whole flipbook texture. So let's write a function that modifies our UV. So it's going to return a UV coordinate. So it's a vector 2, and let's call it flipbook UV. And it's going to take in our original UV, and it's going to take in the size of our flipbook, and also which frame out of this flipbook should it return. Alright, so first things first, let's get the floor of the frame, because we're gonna pass in time here, and we don't want it to scroll from one frame to the next. We want it to go from this frame to the next frame. So so we kind of get rid of the fractional part of it. Alright, so to calculate the which column our frame is, we're going to get the modulo of the frame and the number of columns we have. In other words, the size.x. So the modulo gives us the remaining parts of a division. So for example, our flipbook is a 5x5 flipbook, and let's say we want to sample the 8th frame, and we start from 0. So the 8th frame would be at index 7. So 7 modulo 5 gives us 2, which means the 8th frame is going to be on the 3rd column, because again we start at 0, so 2 means the 3rd column. And for the row, we're going to divide frame by the number of columns we have. So again, for example, if you want frame 8, that would be at index 7, and 7 divided by 5 gives us something like 1.4 or something. So if you get the floor of this, it gives us 1, which again we start at 0, and 1 means the 2nd row. So for example, if you want to sample the 8th frame, it would give us the 3rd column and the 2nd row. But then we want to return that in UV coordinates, so we're gonna add this as an offset to our UV. But then UV coordinates are normalized. They are within a 0 to 1 range, and when we add an offset to it, it pushes it outside that range. So we want to make it normalized again, so we're going to divide it by size. Alright, so now we can use our flipbook UV to create a UV. So flipbook UV, we're going to pass in our UV, the original UV. The size of our flipbook is going to be a uniform flipbook size. And we're going to pass that here, flipbook size. And which frame do we want to sample? Well, we're going to use time for that, so let's create a float variable called lifetime, and this is going to be the fraction of time. Now, the reason we're using fraction is because, well, the time built in keeps increasing, but we want a value between 0 and 1. And the fractional part of time just keeps going from 0 to 1. Kind of like looping too. So we can also add another uniform for the speed of the speed at which we play this flipbook, and we can multiply it with time. And then here we can pass in lifetime multiplied by the total number of frames that we have. So let's create another variable, total frames, and this is going to be flipbook size dot x times flipbook size dot y. But then we want to subtract 1 from this. Actually, we don't need parentheses here. Subtract 1 because, again, we have a 5x5 flipbook texture. 5 times 5 gives us 25. We start at 0, so the 25th frame should be at index 24. That's why we're subtracting 1. And if we multiply our lifetime with the total frames, now instead of using the default UV, we can use our flipbook UV. Now here we need to set our flipbook size to 5x5 because that's what the size of this flipbook is, and we can set the speed to something like 1. Alright, so now it's playing. And now it's a little more obvious, the normal map. You can see, if I decrease the speed a little bit, you can probably see the normal map lighting a little better. Yeah, there it is. Alright, so let's add another uniform here. This one's going to be a vector 3. It's going to be a color, and let's give it a default value of white. And now instead of having a grayscale, we're going to use this mask as a scalar. So we're going to do color multiplied by mask.r. So here's a screenshot of an explosion, and I can just use the color picker to pick some colors from this explosion. And I'm gonna pick some color from here. I think this looks good. And we can copy the hex code here and paste it here. And now we have a tinted or a more dirty looking explosion. I think we can make it a little more saturated to make it a little more brown. Something like that. Alright, so we also packed the back scattering. We packed it in the green channel, so we can set the backlight to masks.g. And now, as you can see, we have some backlighting on the edges. It would be more obvious if we had a more strong light, so let's add an omni light here, somewhere like there. And now if you make this light stronger, you can see that we have some backlighting there. So if I move this light around, you can see that we have some backlighting there. Also, I think it would be more obvious to see the normal map here. You get different shading, different shadows based on where the light is. And we can actually control the depth of the normal map, so we can add another uniform for the normal depth. And we set the normal map depth to be the normal depth. Alright, so now if we change the normal map depth, you can see that the shadows kind of get stronger. If you set it to something less than 1, you can see it looks more flat, but I think something like 1.3 looks good. Yeah. Anyways, so we also packed the flame mask in the blue channel. So if we set the emission to be the masks.b, and let's multiply it with 2 to make it a little more obvious, you can see that we have our flame mask. So we can use that to maybe sample a gradient texture. So we can add a uniform sampler 2D flame gradient. And whenever you want to work with gradients or curves, you want to disable repeat. So you don't want the texture to repeat, you want it to extend. And now here, instead of using a grayscale of our flame mask, we can sample our gradient using the mask, the flame mask. Alright, so if we add a new gradient 1D, and you can pick a bright yellow color. And then we can make it way more orange. Yeah, something like that. Maybe we could start with something really, really bright, something that looks almost white. Yeah, that kind of looks good. But there's something else we can do. We can use a blackbody radiation function and, you know, not have a gradient texture. So here's a blackbody radiation function in GLSL. I'm gonna link that somewhere down in the description or in the comments. We don't need this constant. We can just copy this function and paste it here. So, and instead of having this gradient, we can just have a temperature. Why can't I type today? And this could have a hint range. Oops. And we could go from 0 to 16,000 because this is the Kelvin scale. If you're familiar with it. And let's set it to have a step size of 100. So here, instead of sampling this gradient texture, what we could do is we could sample a blackbody value, or we could, I think we could call it chromosity, chromosity, and we can pass in our temperature. Of course, this temperature is like a multiplier, a scalar. The actual temperature value is in our a flame mask, so mask.b multiplied by temperature. Compute radiance, we don't want radiance, we want chromosity, so and get the RGB. And now we can set the emission to be our chromosity multiplied by some kind of intensity multiplier. Alright, so now if you set the temperature to something higher, you can see we can get different colors. If you move it all the way up to like 16,000, you can see it has a kind of a bluish tint. But we want it to be around 4,500 is good. Now, the reason it looks like shit is, of course, because it's just giving us the chromosity. It's not giving us the radiance, or the intensity of the the brightness of it. It's just giving us the color. So what we can do is we can multiply this with our mask.b again to control the intensity of the light. Now it looks better, but if you want to kind of control the fall off of our intensity of our heat map, we can do that by raising this to a power. So we can add another uniform called heat map fall off or something like that. And then down here we can raise our heat map to the power of our heat map fall off. This is kind of like gamma correction. So if I set this fall off to 1.5, you can see we see a lot less of that very saturated red color. If we set it to like 2, it starts to look like an explosion. Alright, so another thing we can do to make this flipbook animation feel smoother and nicer is to control the speed with a curve. So right now it's playing the animation linearly, but what we can do is we can add a uniform sampler, and we can call it speed curve, and this is going to control the speed. So down here what we can do is we can sample this curve. We can modify our lifetime to be this speed curve sampled with, well, the lifetime. And then we're gonna get the one of the channels, the X channel. Alright, so now as you can see, our speed curve is empty, and we don't have any animation there. If we give it a curve texture and give it a new curve and set it to be red only because we only care for one channel. Now if I edit this curve, you can see that we can control the speed of the animation, and we want it to play it faster towards the beginning, and we want it to slow down towards the end. So I'm gonna make this part, I'm gonna bring this handle lower, and I'm gonna push this one a little higher. So now, as you can see, it starts fast and it slows down towards the end. Now, if you make the playback speed slower, you can really see the choppiness of this animation, because we have 25 frames, and 25 frames is not a lot of frames. You can see the low frame rate here. And the fix for that is to do frame blending. And we already have a texture for that. This one, the motion texture, the optical flow texture. So let's add a uniform sampler 2D for the flow map. We could call it motion vector, optical flow, whatever, but I'm just calling it flow map, so you know, keeping it consistent. We have mask map, normal map, flow map. Anyways, and we can have a float flow strength, and we're gonna set it to a very, very small value by default, because we're gonna use this flow map to basically do UV distortion, and UVs are normalized, so you gotta use really small values when you want to distort them. Alright, so what we want to do is we want to sample our flow map. So it's a 2D vector, and let's sample it from our flow map using our flipbook UV. We want the X and Y, and because textures cannot store negative values, we normalize that value. We encode it to be from a 0 to 1 range, to turn that back into a negative 1 to 1 range. We can multiply it by 2 and subtract 1 from it. And for some reason, the motion vector that I bake from the motion frame app has the x-axis inverted. So to fix that, we can set the motion.x to be the negative of motion.x. Alright, so now what we want to do is we want to sample 2 frames and blend from this frame to the next frame. So I'm going to copy this UV, and I'm going to rename it to UV next. And this is going to be the UV of the next frame in our flipbook. So we're going to add 1 to the frame index. So basically what happens is we want to have a t parameter which goes from 0 to 1 between each frame. So we're going to get the fraction of lifetime multiplied by total frames, and we want to basically use this t to lerp between this frame and the next frame. So we're going to lerp from this frame to the next frame using t. And now, as you can see, we have some frame blending. It's not just going from this frame to the next frame, it's kind of fading out this frame and fading in the next frame. But it still looks choppy because we're not actually using our motion data to distort the frames and blend them. So let's do that. So what we want to do is we want to distort the UV. So UV is equal to UV plus our motion multiplied by the flow strength, obviously, multiplied by T. So at the beginning of this frame, we don't want to distort the UVs at all, but towards the end, we want to distort this frame so that it looks like the next frame. And at the same time, we want the next frame's UV to be distorted in the opposite direction. So we subtract motion multiplied by flow strength, and we want the time to also go the other way. So we do 1 minus t. And now, as you can see, it's shaking because we haven't assigned the flow map. So if we assign the motion vector texture, now you can see it's a lot smoother, but it's still kind of choppy because we need to adjust the flow strength. So if you set it to be too much, if you set it to like 0.05, you can see that the distortion is too strong. But if you set it to be too weak, so something like that, it's basically ineffective. It doesn't do enough distortion to blend it from this frame to the next. So for this flipbook, I think something like 0.014 is the optimal value. So as you can see, it's a lot smoother now. We can actually see a before and after if we add a condition here. So if the flow strength is greater than 0, do these. Otherwise, we don't want any distortion, any frame blending. So set the next UV to be this UV. So we would basically have no frame blending. This is what it looks like without any frame blending. You can see it's pretty choppy. And this is what it looks like with frame blending. Much smoother. Now you can see there's some weird lighting going on. That's because we're applying the frame blending to the mask map, but not the normal map. So if we do the same thing with our normal map, so let's copy this. Alright, so now we're frame blending the normals as well. And as you can see, it looks pretty smooth. Now this is really slow. You probably want to set the speed to something like 0.45. Now that looks a lot better. So if you add a geometry here, some kind of geometry. Alright, so if we add a geometry here, you can see that our explosion will clip with that geometry and kind of breaks the illusion of it being an explosion and makes it more obvious that it's a billboarding quad. So the solution to that is proximity fading. So if we enable or uncomment these lines, we have a proximity fade distance value here that we forgot to copy. So let's just... Alright, so if we increase this proximity fade distance to something like 0.3, Now you can see it's a lot smoother. We don't get that sharp clipping, but we can do a lot better. So we have this depth texture, which gives us a variable depth value for each pixel in our flipbook, and we're gonna use that to control this proximity fade. Alright, so we're gonna add a uniform sampler 2D. We're gonna call it depth map, and we're gonna add a uniform float depth depth multiplier or something. Let's just call it depth. Alright, so what we're gonna do with our depth value, well, first we're gonna have to sample it. So let's call it what do we call it? Depth. So we're gonna sample our depth map. Again, we're gonna do the same thing with the frame blending. So let's copy this from here, paste it here. This is going to be our depth map, and it's a single channel value basically. Alright, so I want to do the same thing I did with the motion vector. So instead of it being from a 0 to 1 range, we want it to remap that to go from a negative 1 to 1 range. So what we can do is we can subtract this depth value from the depth of the mesh, and we can multiply it with our depth. Alright, so let's assign our depth map here and set the depth to something like 2. Alright, so we need to make sure that those pixels are not occluded. So we can set the depth to be 1, so it's always in front. Alright, so now as you can see, we have some depth fading based on our depth map. So I think it's more performant if we just completely disable the Z test, so the depth test disabled. So the reason you're seeing some weird lighting here is because this part of the quad mesh is actually inside this cube, and it's receiving shadow. So if we disable the proximity fading for a second, you can see this part is receiving shadows, and that's why it looks weird. Now, a simple solution to that would be to disable shadow receiving, so shadows disabled. So I guess it would be more obvious if we had a different mesh here. Let me rotate that, maybe that would make it a little more obvious how the depth fading looks. Alright, so let me bring this monkey head here. Alright, so now as you can see, we have some depth fading, and we can increase this proximity fade distance to make it a little smoother. If you set it to be a very small value, you can see we still have that depth fading, but it's like really sharp, the transition between it. We can set it to something like 2 to make it like really smooth. Well, 2 is a little too much, so 1.6, maybe 1.4. Alright, so as you can see, it has some proper depth fading. Now, this depth multiplier, this depth value, this is not like in meters. This is kind of dependent on the camera's near and far clipping planes, so you kind of have to see what value works better for it. You can't really be sure what value is the correct value for it. It also depends on the size of your quad mesh, obviously. I think it would also be more easily noticeable if we make it darker. So let me add a world environment and give it a new environment. Set this to a sky. Alright, so now as you can see, we have some really smooth depth fading for where these two geometries kind of intersect. I think we need to add another property here to control the emission strength. Alright, so instead of using this literal value, we can just use our emission multiplier property. Alright, so now if I set this to something like 5, now it's kind of glowing a little more. We don't want it to be too bright. 3, yeah, 3, 2, 3 works too. Now we're seeing a little too much of the pinkish color, so maybe we can increase the heat map fall off. So let's set that to like 2.2. Yeah, that looks all right. Let me turn the speed down a little bit so you can really appreciate the dynamic lighting here. So I think one thing we can do is, or one thing we should do is set the specularity. So set the specular to 0 and also set the roughness to 1. Did that really make any difference? I'm not sure. You probably want to have this on a particle system, so let's add a particle system, GPU particle 3D, and we're gonna set the amount of particles to 1. We're gonna set the lifetime to, well, 2.5 seconds. And let's add our draw passes. So we're gonna add a quad mesh, and we're gonna set it to be, well, 5 by 5. And for the material, we can just copy the material from here. Copy and paste it. The previous particle dies, the next particle gets spawned, and it continues the animation from where the previous particle died. We don't want that. If you add a particle process material to this, you will notice that a lot more obviously, as you can see. So what we want is we want the shader to use the particle's lifetime. And we can do that using the custom, the instance custom or instance custom.z. So instance custom.z has the particle lifetime in it. So we want to pass that to our fragment shader. So we're gonna add in a varying float. We can call it time. And we can set time equal to instance custom.z. And instead of using this time, we're gonna use the particle's lifetime. Oopsie, nothing happening here. So I think it was instance custom.y. Yeah, it was instance custom.y. So now if we change the particle's lifetime, the speed of the animation changes. So if I set it to 2, you can see that it's playing slower. If you set it to 0.4, you can see that it's playing much faster. So yeah, we probably want to set it to 1 second though. And we don't want fixed FPS, so we're gonna set it to 0 so it can play it as smoothly as it can. Alright, so the reason why this isn't playing the animation entirely is because when we were using time, we were multiplying time with the speed. But now that we're using a lifetime that goes from 0 to 1 for each particle, we shouldn't really use a speed parameter because we're controlling the speed by the lifetime of the particle. So if we get rid of that, this should work fine. So yeah. So now if you set the particle's lifetime to be 2 seconds, the whole animation will take 2 seconds. If you set it to 3 seconds, the whole animation will play in 3 seconds. And you get the idea, right? Alright, so we can add another draw pass here and add some kind of heat distortion to it using our optical flow texture, our motion vector texture. So we're gonna add a new draw pass, and we want this explosion to be the second pass. So I'm just gonna copy it and paste it into the second pass, and then we're just going to clear it from the first pass. Alright, so now we're gonna add another quad mesh here, and we're gonna make it a little bigger than our explosion. So we're gonna make it 6 by 6. Our explosion was well, 5 by 5. And we're gonna create a new shader for this. So let's add a shader material to it, and let's create a new shader. We're gonna call it distortion. And we're gonna copy a lot of the same functionality from our explosion shader. So I'm just gonna copy all of these lines here, the vertex shader. Well, we don't need the blackbody radiation function here, so I'm just gonna delete that. We are gonna need the flipbook UV, and we're gonna need the flow map and the flow strength. So we're gonna copy those and put them here. We're also gonna need the the speed curve and the flipbook size. So I'm gonna copy those as well. We're also going to sample our lifetime and speed curve the same way. So I'm gonna copy these lines as well. Well, actually, we're gonna copy this whole part here, paste it here. All right, let me set the albedo to white color, just to see if our draw pass is actually drawing. It's not drawing. I think we need to change the render priority. Maybe we should. Well, I think on our second draw pass, the explosion, we need to increase the render priority. Alright, so now as you can see, we have another quad mesh, and this one's going to display some heat distortion, or a shockwave if you want. So for that, we're going to set this to be unshaded. So let's set the render mode to unshaded, and we're also gonna disable fog and disable shadows. Actually, we set it to unshaded, so we don't need to disable shadows. It's disabled by default. And now we need to add a sampler 2D uniform for our screen texture, and we're gonna get that with the hint screen texture. And now if we sample our screen texture screen texture with the screen UV, then that quad basically becomes invisible. Now it's being drawn, it's just, it seems invisible. We can confirm that it's being drawn by kind of messing up with the color. So you can see it's being drawn, it just kind of looks invisible. So what we want to do is we want to distort this screen UV coordinate with our motion. So what we're gonna do is we're gonna add our motion multiplied by the flow strength. All right, now we need to copy these properties onto our first draw pass. So I'm gonna copy this speed curve and paste it here in the speed curve. We're gonna set the flipbook size, it's 5 by 5, and we're gonna give it the flow map texture. And if we increase the flow strength, you will start to see the distortion. Not quite, but yeah, there you go. Now you can see the distortion, but obviously we want that to be a little more subtle, so something like 0.05 is good. And also let's add a HDRI sky so that it would be more obvious. Alright, so now that we have a sky, you can actually see it more clearly that we have some kind of distortion going on. Actually, I'm starting to think that we could use some frame blending for the distortion as well. So yeah, let's copy these lines. Let's copy these lines. And here, what we're gonna do is we're going to sample our distortion. .xy. And here we're gonna use distortion instead of motion. And now instead of multiplying this by flow strength, we're gonna have another parameter for the distortion strength. Alright, so now it's a lot smoother. So we don't just want to rely on UV distortion, we also kind of want to make it a little blurred, to make it seem like heat distortion. So I'm gonna reduce the distortion strength, and instead we're going to make it kind of blurry. And the way we're gonna do that is by using the MIP map level of or by sampling a higher MIP map level. So we could just use the length function and pass in the distortion and multiply this with like a big number like 16 or something. And now whenever we have a lot of motion, it also kind of becomes blurry. I think we made this mesh a little too big, so 5.5 by 5.5. Just a little bit bigger than the explosion itself. Also, I think we're blurring it a bit too much, so maybe let's add another parameter for the blur strength. So I think 8 is a good value. It kind of blurs it, kind of makes it look like heat distortion. I think we could make the explosion a little faster. So one of the benefits of using the particle's lifetime is that I can change the particle's lifetime, and I don't need to adjust the speed of the two draw passes separately. Well, let's make it 6 by 6. I'm a little indecisive, you know. And now if you look at it closely, you kind of see some kind of heat distortion going on. That's pretty cool. Now there are a lot of things you can do to improve this even further. So for example, you could add lights for the explosion. So right now, if we make the scene dark, you can only see the flame, but the flame is not really casting any light to its surroundings. So for example, if you have like a plane here, so you see we're not casting any light on this. So one thing we could do is add an omni light source, and we could make it, you know, orange, like an orange, yellowish orange color, like that. Decrease the range and increase the attenuation distance. And for this light to not affect the particle itself, what you could do is you could cull it from the second layer, for example, and in the particle, you could set it to be on the second layer. So right now, this light that we've added, this doesn't affect the particle itself, but it affects everything around it. And you can also animate this light to kind of, you know, do that. But yeah, I'm not going to go into that right now. But yeah, that's just something you can do. You can add sound effects and, you know, you could do a lot of things. Alright, so that's pretty much it for this video. I hope you enjoyed it, and as always, let me know what you think in the comments, and you can download the project files for this video from my Patreon, and a huge thank you to all my Patreon supporters. Your support means so much to me. And with that being said, have a nice rest of your day.